Hi, welcome back. Today we are working on a Daikin package rooftop unit. It's a big unit and serving the medical facility reception area where all the patients wait for their turn. So this unit, when I came, already thermostat was set to cool, and when I came here on the roof, both compressor were working fine. Just looking around, I was just looking around without touching anything. Compressor were looking fine, and but I saw some like ice formation on the suction line. So we're gonna open the unit, and I already turned off the power. So let's go. If you can see, the water is dripping out from the compressor suction line. The second one is right there. See all the water and the water on the compressor body. So I believe something is wrong with the blower motor, or maybe the belt is broken or something. So I already turned off the power, so we're gonna open that blower section. Okay, so the belt is fine. It's looking okay, but I can see that because of the ice formation, all the evaporator coil and the concentrate filled with the water. So okay, we're gonna test. I'm just gonna turn on the power and we'll see what happens. Okay, I have turned on the power. Both compressors are on. The blower motor is not working. Condenser fan are on. Nice and hot. Okay. Forming ice on the suction line because of the blower motor is not running. This is the control section. 3 contactors are on. I believe 2 for compressor, 1 for blower motor. So we have to find out which one is for compressor, which one is for blower motor, and we'll check if the contactor is supplying voltage to the motor or not. Okay, so the power is off. This is the electrical section here, and these these two, the top 2 contactors are for compressor, and lower 2 contactors are for the blower motor. So this unit has the option for high speed and low speed, and both speed are controlled by this contactor. I think one is for high speed and one for the low speed, and I just want to test it. We know both compressor and the condenser fan were working fine, so the voltage is fine. So I have disconnected R wire from the thermostat, R wire from the terminal, and I jumped between R to G, and we'll see which contactor will turn on. Initially we saw that this contactor was pulled in, but the motor was not working. So let's turn on the power, and this switch is, by the way, upside down. Okay, so the power is on. Okay, so the top contactor is pulled in. I think I'm gonna check at the lower portion, load side of the contactor, if we have voltage. Okay, I have turned on the power. Now this contactor is pulled in. So these 2 contactors are for the blower motor, as we know. One for high speed, one for the low speed. Now earlier the top contactor was pulled in, but now this time the second one is pulled in. So I just want to check the outgoing voltage at the load side of the contactor. Multimeter is set on the voltage. $596 something. Yeah. Okay. So the contactor is supplying proper voltage. It's a 575 system. So now we know the both contactors are good. So here if we see the motor section, blower motor section, we also have something, the different kind of device here. So we're gonna dig deep into this system through. Okay, so this is our Daikin wiring diagram. So we're gonna check how it is connected, the blower motor and this device through contactor, and we have to identify where the blower motor is. Okay, if we see here, looks like some kind of motor, high and low, and it is connected through this device CB1 and CB2. I don't know if you can see CB1 and CB2. And from the list here, what is CB? Nothing. No, it's not mentioned anything about CB. Okay, let's go further. And from these two devices, it's going to looks like a contactor, because the one side is line 1, line 2, line 3, and other side is T1, T2, T3. Looks like a contactor. It says BC1 here and BC2, and with the list, yeah, blower contactor. If you see here, it says blower contactor. So these two are blower contactor, is these two, and from the blower contactor it is going to that device. Look like a circuit breaker to me, and from this device all the wires are going to the motor, like 6 wire. These 6 wire, 3 and 3. So one side of the 3 wire turn on the motor into the high speed, and other side of the 3 wires turns on the motor into low speed. So look like it's a kind of circuit breaker here. So I have opened the plate here, of course the power is off, and if we see here, it has a list. One side is motor horsepower, voltage, high speed, low speed, setting. Setting means it's amp setting. So our motor is 5 horsepower. If you see, it says 5 horsepower, voltage 575. I don't know if you can see. Yeah. And in the list it says 575. High speed setting should be 5.2. I think it's amps. And the other side should be 2.9. Yeah. So those settings were set by the factory, and I believe one is already they already sealed it. The second one is also sealed, but it's broken. So I'm gonna just verify if it is on the proper amp setting. Okay, let's verify the amps on the motor spec. And if you see here, amps, it says 5.2 and 2.9. I think it's on high speed 5.2, on low speed is 2.9. And if you see the list here, our motor is 5 HP, 575 voltage. Sorry, yeah, here the high speed setting should be 5.2 and low speed setting should be 2.9, which matches our motor amp spec. And if you see here, that yellow knob is very, I don't know if you can see, but this arrow right there and this yellow knob it says 5.2. so looks like this is a circuit breaker for the high speed and this is for the low speed. So those are already set on a proper spec, so we're gonna not touch it, and both are tripped. Okay, so these are on now, so let me just put all the screw back. Okay, so I have turned on those circuit breaker here, both of them. Power is off and jumped between R to G just to verify the motor. Okay, let's turn on the power. It's upside down. So those were trips, but why they tripped? The belt was looking fine. It was scratching initially when the motor was starting. I think I'm gonna replace the belt, but that was not the cause. It's some kind of power issue. Okay, let's test the AC. So I'm gonna connect the thermostat R wire back to the terminal, and we're gonna test the AC. Okay, I have turned on the power, connected both thermostat wire, and I just want to check the amps rating. Five, you can see 5, and 5.2 is our trip setting. So the motor is running on high speed and the amps reading is good, so the AC will kick in and we're gonna test the AC completely. Okay, so both compressor contactors are pulled in. Condenser fans are working. I can see it's nice hot. Warm air is coming. And this is our supply air temperature. I usually do not connect the pressure gauges until I have to. I usually check with the supply air temperature. Okay, it is going down. Condenser P trap is okay. So I'm gonna also check the filter because this customer doesn't have a PM contact for this unit. Okay, so this unit is running from last 15-20 minutes perfectly. Just this unit need a full maintenance, like a belt. The belt is okay, but still need to be replaced. The wheel the both bearing need to be greased. The condenser coil is a little bit dirty, if you can see. I don't know, there's something is huge dirt is deposited here, and because it's very hot air coming out. The liquid line temperature, by the touch I can see it's hot, little bit hot, and because of the condenser coil is dirty. So we're gonna recommend the customer full coil cleaning, filter replacement. The filter were also dirty, belt replacement, and the supply air temperature is 50 Fahrenheit, so which is good. Thank you for watching. Please subscribe.